right, this is a problem that's on your review for your test for 5.1 to 5.3. And your book really doesn't talk about this, but this is something we need to know how to do. And it's solve equations by completing the square. Okay. When we complete the square, a lot of times we're putting an equation into vertex form, but we can also solve equations that way. For instance, number 4 on your review is x squared minus 5x minus 16 is equal to 0. And you're asked to find the x-intercepts. And then the x-intercepts, the vertex, blah, blah, blah. You're supposed to graph this thing, okay? Now, if I complete the square, I'll put it in vertex form, and I'll know what my vertex is really quickly. But also I can solve when I complete the square. Do you notice that this one doesn't have a y right here? It had a 0 already. We can set y equal to 0 when we want to find our x-intercepts, and that's one of the reasons we even do that. Let me get rid of that. It's one of the reasons we do that when we're, completing the square. But if I want to solve, I can do this. I can complete the square. Let me go ahead. Remember, when I complete the square, I move the constant over to the other side. I have to check that x squared term. It's just an x squared. That's good, because if it weren't just an x squared, I would have to factor out what number was in front of the x squared. So right now I have x squared minus 5x is equal to 16. When I complete the square, I take the b term, and remember when we're talking about a's and b's and c, we're thinking about labeling this equation ax squared plus bx plus c. Now, if I've had to divide something out, that's going to make that whole b issue a lot more complicated. We would deal with that in class on a different problem. But my b in this case right now is negative 5. So what I'm going to do is add negative 5 divided by 2 squared to both sides. Now, negative 5 over 2 squared would be 25 over 4. So what I really have, I might not even want to write it that way over there. I might just go, oh, that's just 25 over 4. And then, so I'll simplify that in a minute. Let's go over here. What I have created when I added b divided by 2 squared is one of those perfect square polynomials. And you write down your x, and then whatever's inside of here is what you write down as your perfect square. So we get this. Okay, now, I'm going to go ahead now and look at simplifying that right-hand side. I need to get a common denominator of 4, so I'm going to multiply by 4 over 4. So I have 64 over 4 plus 25 over 4, which would be 89 over 4. So now I have x minus 5 squared is equal to 89 over 4. So let me write that down. X minus 5 half squared is 89 over 4. If I want to solve, if I were going to put this in vertex form, I would at this point be scooting the 89 over 4 to the other side and then putting my y back in. That's how I would do vertex form. But if I want to solve it, here's what I do, which is something that your book, I don't believe your book has you do, and I want to make sure you know how to do it, so we're going to do some problems like this. If I have something squared with an x in it is equal to a number, I can solve by square rooting both sides. And remember, when I square root, there's a positive root and a negative root. You always have to do that or you're going to miss half the problem because there are 2 answers to this and not 1. So what I get is the square root of something square. I just get what's inside of the square root. That's plus or minus the square root of 89 over 4. And if you remember, when you're square rooting a number, you can just square root the top separately from the bottom, so it's the square root of 89. It's not a perfect square, but the square root of 4 is 2, so I'm going to write it that way. So x minus 5 halves equals plus or minus square root of 89 over 2. Now we got to simplify a little bit. Oh my goodness, I have just been talking away and didn't realize that I did not turn on the recorder. Okay, so we had, if you go back up to the top, right here, I just had recopied. I'll go back through this. I had just recopied this, and I wanted to solve for x. So I added 5 halves to both sides, and I ended up with x equal plus or minus square root of 89 over 2 plus 5 halves. Because addition is commutative, since I'm adding plus or minus square root of 89 and 5, I could just say, oh, that's the same thing as 5 plus or minus square root of 89 over 2, and say, oh, there's a common denominator there. Okay, now this means there are 2 answers. One answer is 5 plus the square root of 89 over 2, and one is 5 minus the square root of 89 over 2. So you need to know that's 2 answers, and you could put this in your calculator and get a decimal approximation, but these are the exact answers right here. And so if you just need to realize that's two answers, not one weird looking answer.